We're going to get started with these 5-minute reports. First, been asked to remind you or tell you about a sign-up sheet on the outside there for cab sharing. If you're heading to the airport, there's going to be a list out there where you can share the cost of getting back to the airport. First we have Perry Ford to talk to us about IBL for pre-service elementary teachers with flipping. I hope that means flipping the classroom and not flipping off the students, which I want to do sometimes. And next is Sarah Bleiler and then Gina Jackson.
Okay, so I'm Perry Ford. I'm from the University of Nebraska at Kearney, and I actually changed my mind on what I was going to talk about. I wrote that on Friday night or something. But I do teach content courses for math elementary teachers, middle school and high school, and I started flipping my courses 2 years ago and really have just been excited about the extra time it allows me in class for working on inquiry-based learning activities, and I think that came up in lots of talks, and it was so wonderful. And then Dale talking about this is his first visit here, and it's also my first visit, and why did it take me so long to get here, and it's just this wonderful community. And so I was inspired by Jackie to repeat an activity that I did a couple weeks ago. We're all talking about inquiry-based learning, and this activity I did is a chalk talk, or for us, it's a marker talk. And the rules for our chalk talk are that there is no talking, so it is silent. And I think just talking with Cindy, she mentioned, when you hear those discussions, it's hard to tune them out. So having this quiet time is really great for gathering our own thoughts. And so I'm going to let you think for a minute and then write any thoughts, questions, or responses on the paper. And it can be right side up, upside down, inside out, I don't care. And then as you read others' comments at your table, you might draw lines connecting ideas that are the same, or maybe their comment inspires you to write something else. So don't feel limited to just write one thing on there as well. Discussion is, what is IBL? So we'll just take a minute to think about that. Okay, so our think time is over, but it is still a non-speaking activity, just using our markers to talk. And when we are finished with our time, then I'm going to post them out on the windows, and you can check them out on your way out the door. So thank you, guys.
So take 30 more seconds while Sarah's making her way up here. Hi, Ed. I'm just saying hi. And after Sarah, Gina Jackson, and then Jeffrey Pear.
Good afternoon, everyone. Sorry to interrupt your silent activity. You can continue as I speak. My name is Sarah Bleiler. I'm at Middle Tennessee State University, and I'd like to talk to you today just a little bit about a project that I'm working on with some colleagues about interpretation of the Common Core state standards. So thanks to Dale, I imagine all of us have heard of the Common Core state standards. How many of you, show of hands, have read the standards? Okay, pretty good turnout. All right. So in our work, we're really interested. We've been working with a group of 60 grades 3 through 6 mathematics teachers. And as we were working with them in their professional development program, we found that they had some interesting interpretations of some of the standards for mathematical practice. Dale told us there are two parts, right? The standards for mathematical content, which are the math standards that are outlined by grade. And then also there are the standards for mathematical practice, which are sort of the processes and proficiencies that we expect students to engage in across all of the grades, K through 12. So in our work, we found some surprising interpretations, and I'd like to share a couple of those with you, and then I'm going to ask for your input for our research project. So that's what I'm here to ask you a favor today. Okay, so first of all, the second standard for mathematical practice is reason abstractly and quantitatively. Okay, so think for a second about what that means to you, how you might interpret that standard. We had many teachers in our program, and keep in mind these are grades 3 through 6 mathematics teachers, who would speak about things like Picasso and thinking outside of the box. So abstract thinking, meaning doing something in a different way. Okay? Which was different than how we as math educators and mathematicians in our group interpreted that standard. So just keep that in mind. Another one with a lot of interesting interpretations is this model with mathematics standard. So model with mathematics, the most prevalent interpretation we had from our sample of teachers was a focus on using concrete materials to model a particular mathematical concept to help students better understand that concept. Okay, so using manipulatives of sorts. We also had a group of teachers that were middle grades teachers that were working together in a PLC, professional learning community, and they were trying to come together as a group and determine how they would help their students better understand this standard. And how they summarized it for their students was, are the students showing their work? And if they're showing their work, then they're modeling with mathematics. Similarly, in that same PLC, the group of teachers said, for standard 7, look for and make use of structure. If students are organizing their work in a structured manner, then they're accomplishing this standard. Okay. So there are some issues of interpretation that I could see from your faces, that you may interpret some of these standards differently than some of the teachers that we've been working with. So what we are trying to do is answer these two questions. First of all, we'd like to know in what ways stakeholders, and by stakeholders we're considering 3 groups, K-12 teachers, mathematics teacher educators, and mathematicians, how they interpret these standards for mathematical practice. And then what are the similarities and differences across these groups in terms of interpretation? Because even in the mathematics and mathematics education communities, some of the language is different. So we'd like to answer these questions so that we can have a better sense of consistently implementing these standards across the grade levels. So that's where you come in. As mathematics education or mathematics faculty, we are really interested in how you interpret these standards. So we have a survey that we've made, and we're collecting data right now. And so if you're interested in helping us out here, you can find the link to the survey right there, the direct link to the survey, or you can email me, sarah.bleiler@mtsu.edu, okay? And I can send you the link that way. And if you have colleagues who would be interested in filling that out, that'd be great too, okay? And then 2 more recommendations that we just have as a research group. First, we encourage all of you to really dig into the Common Core state standards. As Dale said, even if you are not a teacher educator by name, we all are educating teachers, even in our content courses. So it's really important that you're using that language and that you're familiar with the language of the Common Core so that our teachers can have a better sense of how mathematicians are talking about this language. Okay. Thank you.
I'll need the document camera, please. So a little bit about who I am, since I'm not just some kind of stranger up here. I'm Regina Jackson from Auburn University. I work as a lecturer, so I have really large classrooms, lower division courses. The way I'm connected here is I'm a student of Michelle Smith. I'm a math granddaughter of William McCavier, and met a lot of people over the years. So I came in this time very excited because, like I said, I have these very large lecture classrooms. Always had a hard time figuring out how to use IBL, Modified Moore in these type of classes. And I went to the talks and I was a little bit disappointed. There's a lot about flipped classrooms, and so I kind of want to point out some things that are different about a flipped classroom and inquiry-based learning. Okay, so I took my time after getting a little disappointed and went and got, so this is, after looking at a couple of websites, this is the definition for a flipped classroom. A model of teaching where homework is traditional lecture videos or notes viewed outside of class. Class time is spent on assignments, group work, or presentation, and/or presentation. And some sites call these IBL lessons. In my opinion, if you already give them the content and a video lecture beforehand, it is not IBL. It's not inquiry. You've already given them the content. But I wanted to show you the difference. Here's the definition of inquiry-based learning: model of teaching which begins with posing questions, problems, or scenarios. And the key word is begins with. Students identify and research issues and questions to develop new knowledge. So if you're giving them videos beforehand and then asking them to do an inquiry project, for that you're not doing inquiry, you're doing reinforcement, which is wonderful. Student engagement is still wonderful. I do think a flipped classroom can be IBL, but what happens is it becomes more of our definition of a modified Moore method. The definition of modified Moore method is seductive manner of instruction where content is presented by students. Students are given a list of definitions and problems to be proven and then presented in class. So you are giving them stuff outside of class. They work outside of class and then they come in and work together, or they work together and do other things. But I think if you're doing a flip/IBL, then if it is, either your flipped content and your IBL should be separate to really call it that, or you're actually doing more of a modified Moore method. Okay. Thank you.
Okay, next we have Jeffrey Pear, and then Tom Hall, and then Ed Parker.
Hello, good afternoon. I am Jeffrey Pear from Middle Tennessee State University. I want to talk about communication between mathematicians and mathematics educators. First, let me give you a little bit of background, some insight into my background. I have an undergraduate degree in philosophy and a minor in physics. After I graduated, I needed some money, so I started tutoring mathematics, physics, mostly at the undergraduate level. And I really loved teaching, tutoring, and I wanted to teach at the college level, so I pursued a master's degree in mathematics. And I found that I loved abstract algebra. I did a thesis in graph theory, and my professors really supported me. They encouraged me to pursue mathematics at the PhD level. Not all of them were happy when I decided I wanted to pursue mathematics education. At Middle Tennessee State University, we have a new mathematics and education PhD program. I'm just finishing up my first year of doctoral studies. And I know there's been this hostility between the two groups. I'm not really sure why. Like I said, I'm new. But I think that we have this vested interest and we can learn so much from each other sharing visions. First, I'm really interested in proof research. And I want to know what it's like to be a mathematician. What does a mathematician do? And we want students in the K through 12 classroom to be actually doing mathematics. So mathematics educators need to talk to mathematicians to get insight into the actual practice of mathematics. We need mathematicians for that. Also, we've been studying this student-centered, inquiry-based instruction for decades. And it's not easy to get our teachers to implement that instruction, and it can be challenging. And so I just want the mathematicians to know that math educators can be a support. If you're having troubles in your classroom, like how to facilitate that small group work, the discourse, just reach out to me, another math educator you've met at the conference. I think we have a lot that we can offer each other. So at Middle Tennessee State University, like I said, we have this new program. The mathematicians and mathematics educators are in the same department, the mathematics department. And we've had a lot of opportunities for collaboration, just getting some discussions going. One particular course redesign project with pre-calculus, we have this really great mathematician that I really respect, working with a mathematics educator to make the pre-calculus more student-centered. They're using a totally new curriculum. And what's really exciting is the mathematician's transformation. He's been teaching 20 years. He uses the modified Moore method in his graduate courses, but in the pre-calculus classes, he's always been a traditional lecturer. And this past semester, working with the mathematics educator, he said that it's totally changed the way he views teaching. He's never going to see teaching in the same way again. And I've been really encouraged by his transformation. And so at this conference, I've had a great opportunity to engage in lots of discussions with many different people from diverse backgrounds. And I just wish that we could all keep that going. It's great that we can do it here, but when we go back to our practice, we don't need to always be in these isolated communities where we all have our own ideas, but we can make these bridges. We have lots of new people in these communities, and I hope that we can do that in the future to support our students in learning mathematics. Again, I'm Jeffrey Payer from Middle Tennessee State University. Thank you.
Hello. I'm Tom Hall. I'm from Western New England University, and those of you who know me know that I'm really into origami. In fact, I talked about origami a little bit last year during one of these 5-minute things. I want to give you all a little bit, or show you something that's a small piece of the origami math universe that is very inquiry-based and you might like. So if I could have the document camera. Really, I just want to mention the work of a Japanese retired biology teacher, actually, named Kazuo Haga. And he is a well-known origamist, and he, after retiring from biology teaching, started inventing lots of really cool little origami geometry problems that I love giving to students and just having them play with. They're very open-ended, and there's a lot to learn from them. And they're unusual. They're not things you would have seen before. He's written a whole book on these things, the title of which is there, and I want to show you one of them really quickly. So here's a square piece of paper. It's colored on one side and white on the other, and I'm going to label, well, except I don't have a pen. I'm going to label one corner, say the lower right-hand corner. Yeah, thanks. I label the lower right-hand corner A. And now I'm going to fold A anywhere I want. And the question is, what's the shape of the flap going to look like? Let me demonstrate. So it looks like a triangle. Could it look like any other shape if I had folded it somewhere else? Yep. Maybe a rectangle if I was really careful. Right, or it could be a quadrilateral. Could it be any other shape? What if I had folded it somewhere like here? So you can get pentagonal shapes if you allow your point to go somewhere off the square. But here's the real question. Looking at, say, this square piece of paper sitting in the plane, diagram the various regions you could fold the point A to get a triangle-shaped flap, or a quadrilateral-shaped flap, or a pentagon-shaped flap, or maybe something else. This is a great example of what Kazuo Haga does. He has lots of activities like this. I'm not going to give the answer because it's too fun. And if that appeals to you, he's got a lot more, and they're all in this book that came out, I don't know, like 5 years ago or something, and it's just a nifty thing. Yeah, so that's all I wanted to say, but I do want to mention one other thing. Some of you may have gone to Sarah Marie Belcastro's talk on the program Mathily. I'm an instructor in that program, and we put out problems from Mathily, cool math problems that are, very fun to play with. They're on the exam assessing readiness that we use for that program. This is a program for high school kids. If you like cool math problems, they're on one of the tables back in the middle room there, I think on the table labeled math. Go get them. There's still some left, and they're fun. Okay, thanks.
Okay, we have Ed Parker, and then Lee Mahavier Peterman, and then Gary Richter.
My name is Ed Parker. I'm Professor Emeritus, James Madison University. I wanted to follow up on something I heard yesterday. The question was raised during the panel discussion, what do you see as the direction of the legacy movement? And the panel addressed it, but I wanted to address it again with the 24-hour interlude to think about it. If we're going to see where we're going, we need to look where we've been. And I want to propose what I hope is at least a semi-appropriate metaphor. Imagine, if you would, a virus that instead of being a disease spread wellness. And think back to where IBL, as represented by Moore Method, would have been before the legacy movement sort of coalesced. The virus was very highly localized in special hosts, and those hosts were in very small colonies, and they were widely isolated. Follow forward in time just a tad into the second generation beyond Moore, where the persons who had been infected by the virus largely were not at R1s anymore. They were in regional universities mainly. And so the virus is spread in hosts that are harder to stamp out because they're not as localized anymore. But at the same time, since the business of the regionals is slightly less mathematics all the time as the R1s, it begins to take on character that is harder to treat, because the work that the constructivists have done, the work that discovery learning persons have done, begin to make a hybrid, and it begins to grow. I told someone recently that one of the greatest consolations I take from looking at the current state is that I no longer think that even a purposeful enemy could kill the virus, because it's widespread enough now, and it's taken on enough different personifications within its contacts with other viruses that spread wellness of a slightly different type, that if you tried to kill it somewhere, then it would just get stronger other places. My view of where the legacy movement is headed is that we take this virus and turn it into an epidemic.
I'm Lee Mahavier-Peterman, and Mr. Harry Lucas recently came across an article that really interested him, and thank you, Mr. Lucas, for asking me to tell all of you about this article. It's in ZDM Mathematics Education. It's a commentary paper by Alan Schoenfeld and Jeremy Kilpatrick titled A U.S. Perspective on the Implementation of Inquiry-Based Learning in Mathematics. The paper has not been released yet, but EAF can provide it to you once it is, so just simply contact EAF and you can get your own copy later. I'm going to give you a quick summary of what's in this paper. It discusses issues related to the potential adoption of IBL projects in math in the United States at the K through 12 level. It starts with the implementation of IBL using a project in Europe called Primus, Promoting Inquiry in Mathematics and Science Education Across Europe. This was a successful project. The U.S. educational system is actually a collection of systems, the paper points out, and goes on to give us an interesting history lesson. We're a collection of individual states, and each of the 50 states has had its own requirements for setting curriculum policy, standards for students' performance, assessing student performance. The No Teacher Left Alone Act, excuse me, the No Child Left Behind Act of 2001 and AYP, Annual Yearly Progress, provided very strict penalties to schools, and tests became known as high-stakes tests because so much was at stake, whether a teacher would earn a raise in salary or even retain her job, whether a school would even remain open, all hinged on student test scores. So teaching to the test became an increasing aspect of instruction. A large part of instruction has become preparation for the test. If any curriculum project was seen as being at variance with the goal of test performance, the likelihood of its adoption was nil. Then in July 2009, President Barack Obama announced the Race to the Top, and it provides incentives for the creation of new and improved standards, offering funding to consortia of at least 5 states that could agree upon standards and assessments. The Common Core state standards that we've all heard about, CCSS, in mathematics, CCSS-M, are optional. But as the enormity of the challenge of building consensus standards in a short time frame became apparent, more and more states adopted the Common Core ones. Right now, 45 of the 50 states have adopted it. So for the first time in the history of the U.S., there is sort of a national set of standards. The high-stakes assessments mentioned were skill-oriented multiple choice tests that did not ask for reasoning or meaningful problem solving. Research indicates that students who study from a curriculum that gives attention to skills, concepts, and problem solvings will do quite well on a skills-oriented test. I'm proof of that. It takes a brave teacher, however, to maintain a broad focus in instruction when the fates of his or her students, and possibly those of the teacher and the school, depend on how the students will do on a narrow skills-oriented test. So looking at new assessments, 2 parallel assessments are being developed currently, and each state can opt to use one or the other. One's called PARCC, and one's called SBAC. PARCC is for Partnership for the Assessment of College and Career Readiness, and SBAC is Smarter Balanced Assessment Consortium. The first high-stakes implementation of these will be in this coming school year, 2014 through 2015. The Common Core lists content and learning goals by grade level, and so this will be the first time that across the U.S. things will be somewhat the same. Another change in the Common Core is the emphasizing of not just content but practices. They highlight practices such as making sense of problems, reasoning abstractly, and on the Smarter Balanced assessments, there will be scores for concepts, problem solving, communicating, and so on. So the likelihood of an IBL project taking root would definitely depend on how the project could sell its version as being consistent with the framing of the Common Core. The article goes on to address specific issues that may be a challenge.
Okay, next we have Gary Richter and then Dana Olenoff.
Hi, I'm Gary Richter, and I teach at Southwestern University. I'd like to tell you about a conversation I had this morning with a local bus driver. I was slow to register for this conference, and when I went online, I found that all the hotel rooms that had been reserved for the conference were taken. As a consequence, I've been staying at a Best Western, which is about 6 miles that way, and a 40-minute bus ride. This has not been a hardship because I have got to see Denver, more of Denver than I would have if I had stayed here. I got on the bus this morning at 6:45, and there were probably 2 other people because who's going anywhere at 6:45 on a Saturday morning? I sat up front, as close to the front as I could, so I got a good view out of these huge front windows. And at some point, the bus driver asked me how long you staying here. Well, I told him. He said, "Well, what are you here for?" And I said, "Well, I'm going to a conference." "Well, what kind of conference is it?" I said, "Well, it's a math conference. I'm a math teacher." He thought for a while about that. "Well, what do you do at a math conference?" Well, this was a hard question because, essentially I told him about IBL without using the words IBL or more method. I said, instead of having a class where the teacher lectures, students spend the class time presenting their own work, which they've done outside of class. And he liked the idea. He thought that sounded great. He asked, how much of a course is taught this way? And I said, well, ideally, the whole course would be taught this way. He asked, do all universities teach math this way? I said, no, but now my estimate was 10. I said, I hope 10 to 15 years from now, it will be the case that virtually all universities teach math this way. And then he began to think locally. He said, well, there's a college down here, CSU. Do they use this method? I said, I don't know. I don't know anybody from there. I said, some places are friendly for it, and some places are hostile to the method, which surprised him. He thought it sounded like such a good idea that he had trouble understanding why people would be hostile to the method. And so I guess thinking about that, he said, what do you do to go to an administrator and persuade an administrator that you should be permitted to teach like this? And I think this is a great question, to which I don't have a short answer. In fact, I'm not sure, one size doesn't fit all here. At some point he mentioned that he was aware that things were changing in the world and that there's more technology in education, and I said yes. That actually I see that some of that technology threatens my job, because you can go online now and hear a lecture from a professor from Harvard or Stanford, and it doesn't cost anything. He had not heard of MOOCs, these massive online open courses. So I explained MOOCs, and I said, you can sign up for those for free, which amazed him. And he started thinking about education, the cost of education. He said he knows somebody who just graduated with $30,000 of student debt. And he told me something that surprised me. He said that his employer, which is the bus company, offers all its employees up to $1,500 a year to spend on college courses, which sounded amazing to me. I told him about the MOOCs, and he found the weakness right away. He said, but if you're taking one of those courses, how do you have an interaction with the teacher? And I said, well, that's exactly the point. You see that right away. Anyway, I talked with him for about 30 minutes, and I was impressed at his enthusiasm about the idea and the very thoughtful questions that he asked me. Before I got off the bus, I asked him his name. His name was Jeffrey. And I told him that years from now, when I think back on this conference, I'm going to remember my conversation with him. And I told him that I was going to tell my friends about it, which I've just done.
Okay, our last 5-minute talk is going to be Dana Olanoff, and then Victor Piercy has a quick announcement.
Hi, my name is Dana Olanoff, and I teach at Widener University outside of Philadelphia. And I asked if I could do this at the very last minute because I was inspired by the last plenary that we just had. I'm here with my colleague Amy Hillen from Kennesaw State University, and we're both math teacher educators trained in math education, and this is our first time at this conference, and we've really enjoyed it and learned a lot. And so during the plenary, we were watching this Allie video of this 5th grader solving some fraction comparison problems, and we were very excited when we saw this up there because we actually have an activity that we use with our prospective teachers that is based on watching this video and doing some fraction comparisons. So if I could just get the document camera turned on. Dale Oliver asked us to share our favorite tasks for using with prospective teachers, and we've been designing some tasks on fraction comparison. I'm a part of a group of 6 people who work on designing what we hope are rich IBL type tasks for prospective teachers. And so our website is www.mathtaskmasters.com, and we have currently 5 tasks that deal with fraction comparison, and we're going to be working on some other ones. So we'd love for you to take a look at our website. If you teach the tasks, we'd love to hear some feedback, and please feel free to contact us. Thank you.
I forgot to say this yesterday, and so I'm saying it now. There's on one of the easels, there's a sign-up sheet if you're interested in hearing more about the idea of putting an IBL special interest group together through the MAA. So if you haven't already signed that and you're interested, on your way out, please put your name and email on it, and I'll take that home and I'll be in touch. Thank you.
Hello, everyone. So it's time for us to wrap up. First, as you should know, the MAA is one of our joint sponsors here, so I'm going to invite Linda Brady to come up and say a few things.
Well, I said already what a privilege it was for me to be here. I've enjoyed the last couple days with all of you, and I hope that, I hope that you'll plan on attending Math Fest this year. It's in Portland. The joint math meetings in January is in San Antonio, and there are contributed paper sessions that we're still accepting abstracts for that are on inquiry-based learning at JMM. And I was thinking about, I guess what I'd like for you all to take away with you today, particularly if you're not very familiar with MAA, is that we think of our work from the perspective of, like, one of our primary goals is to help you do your job better. How can we support you? Like, we understand that there are more and more demands on your time and fewer resources for doing your job, whether it's travel funding or just time. So any ideas that you have for ways that we could help you do your job better, we're all ears. So email us anytime. You can find our contact information on our website, www.maa.org. Thank you.
Thank you, Linda. So I also want to close with some thank yous. So first of all, thank you to all of the participants who helped make this a successful and wonderful experience for the rest of us. You are the reason the conference came off when we actually had sessions. Thank you very much. Thank you to our plenary speakers, Mike Starber, Julian Florin, and Phil Hotchkiss, Karen Sachs, and Dale Oliver, for sharing their ideas with us. Thank you very much. Okay, maybe we could do this quicker if we wait just a second. Thank you to our volunteer moderators. Many of you gave up a little bit of your freedom at the conference by helping out, and we really appreciate that. Thank you to the organizing committee. And then for funding, please, thank you to the MAA for being a joint sponsor. Thank you to the Educational Advancement Foundation and its staff, and in particular for Angie and I, our big contacts were Albert Lewis and most especially Norma Flores. Norma is the one who makes all of this really come together. And again, although I know he's not here, thank you to Mr. Harry Lucas for making this possible. And I would be remiss, thank you to our audiovisual crew, Banning, and the guys from the hotel. Thank you very much. Okay. So Linda already mentioned some upcoming IBL events at MAA meetings. Please keep your eyes open for those. And remember, next year we'll be back in Austin, June 25th through 27th. And I'll leave you with Angie. Thank you.
This is not made for little people. Okay. And thank you also to TJ. It's been a great team working together, powwowing, and again, thanks to Norma and everybody for helping us. One thing I just want to leave you with is, I don't know how many of you are here for my student panel, but one of my students said the Calc 2 class is getting together for reunion next Saturday for Calc 2 reunion. Now that's not this year's Calc 2, that's last year's Calc 2 that they're still getting together. And the family, and he said it's a math family, and that math family's grown. We've taken in teaching assistants, we've taken in people that come to the math help room, and that really hit me because that's what this is. My math family, I started going to these conferences in 2008, and I can't stop going to them. Once I started, I feel like this is my family that I see several times a year, but it's a big reunion at this conference, and the family grows every time we come. So if you're a first timer, hopefully you'll come back. If you've been coming, hopefully you'll continue to come and bring your friends. And the last thing I want to say also is Mike Starbird's Right Time, Right Place. Hopefully you've all felt like you were at the right time and right place to come here and be part of this family and welcome other people into our community. So thank you all. Feel free to contact us anytime. There's many resources at the MAA, the AIBL, Math Ed Matters blog, the AIBL blog. There's a lot of resources to keep in touch throughout the year. So thank you, and hopefully we'll see you all in Math Fest and again next year at this meeting and the joint meetings. Thanks.
Travel safe, everybody.